totally gypped me.
Oh, come on.
Got this reference that was supposed to be a triangle. Yeah, I don't know.
It's even folklore. I've seen it on a website. Crazy stuff or whatever. Photos you'd never believe would work or whatever.
Yeah. No, it's a complete gyp. I don't know why we wasted time coming down here.
It looks like there's something sort of going on here. Is that a triangle now? What's that?
Oh my god.
Is that a triangle?
Oh my god. That is quite freaky.
I think that all over. Yeah.
Okay, ladies and gentlemen, thought that was kind of neat. We're talking about triangles here, and there is optical illusions, which are very cool and very neat, and you really, incorporate a lot of geometry with optical illusions. So that one was kind of neat to see. I think that was in Australia, I believe, but. Yeah, just thought it was something neat to see and, change it up a little bit. Okay, so we are getting to some of the big league stuff right here, okay? This is like, where it's at. This lesson right here and the two to follow this, so we have 9-4, 9-5, 9-6 are really the most important 3 lessons you're going to learn all year as far as taking this math to the next level. This stuff can be applied to pre-calc, which again, I talked to you guys in class. The majority of you will be taking soon enough, whether it's honors pre-calc or regular pre-calc. So cannot stress enough just how important this is. Here we go. There are 2 special right triangles. Okay, special right triangles are unique to have a lot of cool properties go along with it. The first one is a 45-45 9-degree triangle, and the second one is a 30-60 9-degree triangle. Okay, these are the 2 big ones. And we've been talking about our last chapter all about ratios. Well, with these special right triangles, we have special ratios. So the first thing we're going to take a look at is the ratio for a 45-45 90. In a 45-45 90 triangle, the hypotenuse is √2 times as long as each leg. So what we do here is, I'm going to show you guys just the ratio. Here's my right angle. Okay, each of the legs is going to be x, and x, and your hypotenuse is going to be x √2. So the way we write this out is it's a ratio of 1 to 1 to √2. Okay, this is the easy one. It's really nice, not too bad, but the ratio will always be there if you have a 45-45 90 triangle. Okay, there are 2 types of these problems. The first one is absolutely wonderful because it's so very easy. Okay, so here's the deal. Find the value of the variables, 45 degrees. If this is 45 degrees, I know that this must also be 45 degrees because all my angles have to add to 180. Okay, never forget that. So first, you label your legs. So x, and this would be your x √2. Okay. Now I know that the x is already in this problem, so if it helps to create less confusion, you could put a y there if you'd like. I just stick with x because I just tell myself that's the same variable every time. If x equals 7, so these legs are 7, that means that my hypotenuse, okay, with my variable that I chosen here is 7. If I plug 7 up here for my ratio, I get 7 √2, which is my answer. Okay, so look at how nice this is. All right, I did no Pythagorean theorem here. Okay, I just knew, I just knew that 7 √2 following my ratio, 1 to 1 to √2. Okay? Now, for part B, like I just talked about, I'm going to go ahead and let's call this y. I'm going to switch it up a little bit just so I don't create some more confusion with the x's. y √2. Okay? Do you notice how down here I have y equals x? Can't do anything with that. But up top here I have y √2 equals 10. This is the more difficult version of this problem, okay? So bear with me. I want to get y by itself so I can figure out what my legs are for this right triangle. I'm going to divide both sides by root 2. So I get y equals 10 divided by root 2. All right, like we learned a few days ago, we cannot leave a square root in the denominator. So we have to do something called rationalizing the denominator, okay? So what I'm going to do here is multiply top and bottom by root 2. Now up top, I'm going to get, put it over here, 10 times root 2 is 10 root 2. Now on the bottom, I'm going to show you guys step by step here. Root 2 times root 2 is square root of 4. Ladies and gentlemen, what is the square root of 4? Well, it's 2. You see something else I can do nice here. Okay, 10 divided by 2 is 5 root 2. So what you guys have just done, behind my mouse right there, is we found the legs. This right here is 5 root 2, and that right there is 5 root 2. Okay? So 5 root 2, 5 root 2, and 10 are the sides of that right triangle. Now, I will let you guys in a little secret, but we got to keep it just between us, okay? You can't tell anybody. If they're ever giving you for a 45, 45, 90 triangle, the hypotenuse, and it's a whole number, all you do is divide it by 2 and put a root 2 at the end of it. So if this is 10, divided by 2, you get 5, put a root 2 on the end of it. If this was a 12, this would be a 6 root 2. You see what I'm saying? The only time it gets a little tricky is if this is an odd number. Let's say it's a 7. 7 divided by 2 is just 7 over 2, root 2. All right? That's our first one. So let that one sink in for a moment. Now we're going to take a look at 30, 60, 90. With 30, 60, 90, okay, it's a little bit different. Up here makes sense because same angle, same ratio, 1 to 1 to root 2. With the 30, 60, 90 triangle, if the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. So here's another right triangle for us to take a look at. Okay. I'm going to call this my shorter leg. I'm going to call that x. That's your starting point. My other leg, it's a little bit longer, is x root 3. Okay, and important to note this, and I apologize for not doing this earlier, across from 30 has to be your shortest leg. Okay, smallest angle, smallest side. Next biggest side, next biggest angle, next biggest side. And then of course the biggest side's got to be across from 90. So this is going to give us 2x. So here's your ratio, 1 to root 3 to 2. Okay? Now, let's take a look. So our first goal is to recognize our pattern over here. Now, since we have a and b's here, I'm going to go ahead and use x's for my ratio. Okay? Across from 30, we make this our x, just like up here. Across from 30, we make it our x. Across from 60, we make it our x root 3. And then across from our 90, we make it our 2x. So what you're doing here is you're looking for things that can help us out. X equals A. Not helping me yet. 2x equals B. Two variables, don't like it. But over here, x root 3 equals 10 root 3. I like it. So x root 3 equals 10 root 3. Divide both sides by root 3. X equals 10. Okay? So all I'm going to do is go back now. If x equals 10, look up here. A equals x, right? So A is just going to be 10. For my hypotenuse, it's 2 times x. So 2 times 10, 20. There we go. Okay? This is the nicer one. Much like the first one for the 45, 45, 90 triangle, not too bad. Okay? So, all right so far. 10, 20, 10 root 3. Okay? There's your ratio. Now, we can amp up the difficulty just a little bit. Let's look at part B. Across from 30 is your x. Across from 60 is your x root 3. And across from 90 is your 2x. Okay? I'm telling you guys, get in the habit of doing that. X root 3, 2x. If it's 45, 45, 90, do x root 2. Okay? Now, S equals X, not helping me. 2X equals T, not helping me. But X root 3 equals 9. Okay, now I'm on to something. Divide both sides by root 3. X equals 9 over root 3. Got to rationalize your denominator, which we're going to get very good at. Top and bottom by root 3. I get 9 root 3 over the square root of 3 times square root of 3 is square root of 9. I'm hoping, actually, I'm encouraging guys here to do the shortcut, meaning just root 3 times root 3 gives you just 3. Your call. 9 over 3, if I can divide it, do it. So we get 3 root 3. All right, that's what we found X to be. Well, that's what S is going to be. So this side over here is just 3 root 3. Now look over here. See how our hypotenuse is 2 times X? Well, if we found X to be 3 root 3, this is just 2 times 3 root 3. So 2 times 3 gives me 6 root 3. There we go. All's well. Okay? So I'm going to make one more video for you guys. All right, this is a good start. This is the front page of our notes. Again, replay it if you have to. This is not the easiest stuff in the world, but if you continue to set up your ratios, you're going to continue to have success with it. All right? Good luck. We're all counting on you.